All right, today we are here for 7.3, the basics of solutions. This may be reviewed from previous science classes, but if not, that is a-okay. So a solution is a mixture where the solute is evenly dissolved in the solvent. So I used two vocabulary words to define that, so let's define those. A solute is the substance that dissolved. Like salt or sugar. We tend to use those as examples a lot. And the solvent is the substance that does the dissolving, like water, oil, etc. This unit is all about water and water as a solution. So we are going to actually talk about water specifically a lot of the times. So in water, ionic substances dissociate. That means that they break apart into ions. So how does that work? All right, when we draw a solution, we might get something like NaCl. That's regular table salt. Most table salt is sodium chloride. It is going to break apart into its two ions. I see Na and I see Cl. Na is my positive ion, Cl is my negative ion. And so when I draw them in solution, I'm going to draw a little beaker. I'm going to draw some water. And then I'm going to draw Na plus, and for each Na, there's one Cl minus. Let's say I have something like AlBr3. That is going to separate into aluminum. And if I look on aluminum on the periodic table, that is my +3. So Al3 plus and Br minus, but there will be 3 of them. So that means that for every one Al, I need 3 Br minuses. That would be my aluminum bromide in solution. So I want you to try and see if you can figure out what MgCl2 would look like in solution. So break it down into its ion parts, and then draw your solution, pause the video, and then come back and see the answer. Okay, magnesium, there's just one magnesium. It's got a +2 or 2+ ion charge, and chlorine has a -1, but there are 2 of them. So that means in my solution, for every 1 magnesium, I need 2 chlorines, and I'm going to do it twice. On the flip side, if that is my ionic substances in water, covalent substances do not dissociate. They stay together. So that might look like if I have a beaker of water and I'm dissolving something like CH4, my CH4 molecules are just going to stick together. The moral of the story here, I'm going to flip my page for a clean start, is that like dissolves like. In other words, polar solvents dissolve polar solutes, and nonpolar solvents dissolve nonpolar solutes. Sorry, that's messy. So for example, if I had the solvent, I'm going to do some solvent and solute combinations with a model. If I had a solute like calcium oxide, sorry, let me pause. Okay, back to it. So if I had CaO, this is an ionic molecule, which means it's polar. So it needs a polar solvent, something like water. And if it were to go into solution with water, my CaO would break down into calcium and oxygen, and they would dissolve into the solute. So tiny, like that. Whereas if I had something that was nonpolar like CF4, it would need a nonpolar solvent like oil, like vegetable oils are nonpolar. And when it goes into solution in the oil, it's going to stick together like that. To continue on in our notes, we've already defined that water dissolves polar substances. Solutions with water as the solvent are called aqueous solutions. Aqueous solutions have lower freezing points and higher boiling points due to the solute that is dissolved. A Another interesting thing about this is that the more ions that dissociate, the lower the freezing point. So for example, NaCl is going to dissociate into Na plus Cl minus, which is 2 ions. It will have a low freezing point. MgCl2 will dissociate into Mg2 plus and 2 Cl minuses. So that's 3 total ions, which is a lower freezing point. But then you could do something like AlCl3. Aluminum is a 3 plus and 3 Cls. That's 4 ions. That's going to be the lowest freezing point. You can use this method to deal with the frozen roads in the winter. If you just use table salts, you're not going to lower the freezing point by very much, and the water will still freeze into ice. But if you can get a salt that is mixed with multiple different ions, you're going to have more ions in your aqueous solution. This will lower the freezing point significantly enough that you will be able to turn the ice on the roads into water, melt it, and have more safe roads and safe driving conditions in the winter.